Okay, hello, hello. So again, we're starting on page 30 in the packet. We'll take our quick daily look at the calendar. Today is February 6th. We're going to cover something called equations of lines, two different forms of equations of lines. Hopefully some of today will look familiar to you. And then next class in theory is our very first quest. Why do we say in theory? Seems like there's a significant snow thing coming. So let us make a plan right now. If there is no class on Friday, our quest is on Monday, okay? Right? Oh yes, I have answers about the quest. Thank you for reminding me. Right over here. Okay, so there are no resources that you're going to be allowed to use on the quest, no cheat sheet or index card or any of that, so make sure that you have in your memory like any kind of formulas that you'll need to use. Another question was about the calculators. Yes, you can use your calculator for the entire quest. If the only calculator you have is on your cell phone, I'm going to lend you a calculator on Friday because I don't want you to use your cell phone. Katrina? I'm probably going to want to loan you a calculator. Yeah, same thing. Yeah. Okay, all right, and then the other thing, I had said if people wanted to start early, you could get here at what time? 12:30. We're going to move that to even earlier because I have a meeting right after our class this coming Friday. It might be all moot because the class might be canceled, but if we are here on Friday, 12:10 until 2:10, that is when I am opening this room to your quest, okay? 12:10 until our normal ending time at 2:10. I really need to get out of here at 2:15 to get to the other building for a meeting, all right? Okay. And if class is canceled on Friday and we have our quest on Monday, 12:10 start on Monday as well. I have a different meeting right after class on Monday. I have a lot of meetings. You can still show up at 1, but if you want some extra time, show up at 12:10. Is that okay? Like there shouldn't be any classes that anybody's in at 12:10. Bring your lunch. I mean, it's totally fine. Like I know that's lunchtime, so it's totally fine to eat here. Okay, so to be clear again, the quest, as it says here, covers classes 1 through 5. That's everything we did up until last class. So the stuff that we are doing today is not, the new stuff is not going to be on the quiz, all right? And again, we're here on page 30. That's where we'll begin. But if you fast forward to page 35, I think that's where we found that wonderful resource with the practice problems for the quest. So we can just check there real quick. Right. If you go to the middle of page 35, you'll see practice problems for quest number 1. And again, it tells you how to find videos of me going through all of these problems on YouTube. And I will say this, I know that that you are all very busy, and you're not going to have maybe enough time to do every single thing you'd like to do in terms of preparing for this quest. But if you do not make time to go through all of these problems, I think you are wasting an opportunity. When I was in school, if a teacher gave me like practice problems, like I would do those above all else. I wouldn't go over, if I didn't have time, I wouldn't go over old homework or old quizzes or old anything. I would absolutely make sure I made time to do the practice problems. So I'm telling you now, I think that this is an opportunity. At least make time to do all of the problems on this, even if you can't do any other kind of studying. Make sure you can do all of these problems. There's an answer key. There's a PDF on Moodle with the solutions. There's videos of me on YouTube, okay? Yeah, Katrina. I've given you everything I have. Okay, so let's go back to page 30. Again, not going to be on the quiz, or on the quest, but let's see what we can do here. So we'll jump up to number 1, and we'll start in the back. Joe. Page 30, number 1 at the top. Okay, so number 2 here, we're going to sketch the line that has a slope m equals -2/5 and a y-intercept of 0, 3. So this is going to be a new thing for us, actually. Graph a line given the slope and an intercept. So let's give it a shot. The y-intercept is 0, 3. Go ahead and plot the point 0, 3 on the grid. And now we're going to use the slope in a way that maybe we haven't before. We're going to really think about that negative 2/5 as being a rise over a run, a vertical thing over a horizontal thing. Now remember how I said I always like to put my negative in the front of the fraction? I don't do it in this case. I'm gonna choose to put that negative somewhere. In fact, we're going to put it in two different places. First, I'm going to choose to put it upstairs. You can put the negative wherever you want, up, down, or in front. So if I put it upstairs, then I guess what that means is that I'm rising -2. Which way would you say is -2 in the vertical? Is down. So we go down 2. So I'm going to go down 2. It is very tempting to put a dot there. Don't put a dot there. We haven't run yet. So now that we've risen, it's not really a good word because we went down, but we have risen -2, and then we run, so this is 2 down, and then we run +5, left or right. Which way is +5? It's to the right, so then we go 5 to the right. 1, 2, 3, 4, 5, and what can I put right there? We can put a dot. So that right there is another point that's on this line. And frankly, that's enough. You can take a straight edge and connect the dots. Don't do it just yet. Yes? Great question. What if we chose instead to put the negative sign downstairs? Fair? Let's just put it downstairs. Jenny? Okay. So if we say 2, now it's +2. Is that up or down? That's up. So we're going to say 2 up. And then 5 is now -5. Which way is that? That's to the left. So we're going to go 2 up and 5 to the left. I'm going to go back to my starting point. So from the starting point, the 0, 3, we're going to go 2 up. So we go up 1, 2, which seems very surprising because we went the exact opposite direction the first time. But now if we go 5 to the left, 1, 2, 3, 4, 5, we'll put a dot out there. And what do you think about those 3 points? It's all the same line, right? It's all the same line. So should you put the negative upstairs or downstairs? It doesn't matter. Put it both. The top number tells you up or down, and the bottom number tells you left or right, and everything is based on the sign, whether it's positive or negative. Any questions on drawing a line given a point and the slope? Michelle, is that all right? Okay. And then a real quick check. This slope right here, that -2/5, is a negative number. So I'm going to write that here in the blank. Slope is negative. And then we talked about lines being either increasing or decreasing. What is that line right there? That line is decreasing. Remember, you always read the line like you read English, left to right. And if you walk on this line from left to right, that way, you're walking downhill, you're decreasing. And that's something that's just fundamentally true. Any line with a negative slope decreases. Any line with a positive slope increases. Okay, so if we're ready, we're moving on to number 3. We'll go to Dan in the back. Okay, this right here is one of the most important equations we're going to see the whole semester. Y equals mx plus b. Raise your hand if you've seen it before. Good, looks like almost all of us have experience with that line. So we need to know a couple of things about that line. The m sitting in front of the x is the slope. The b, which is the number sitting by itself, is the y-intercept. So let's see if we can use that equation. Down here it says write an equation in slope-intercept form. That's the equation we just had for the previous problem. So let's write it. Y equals something x plus something. I'm just going to put blanks. Every mx plus b equation has that form. Y equals some number times x plus some number. Again, m is the slope. Slope was given for this previous line. What was the slope? What number was the slope? was -2/5. Put the negative upstairs, downstairs, or in front, it makes no difference. I like to put it in front. Plus, now we need the y-intercept, which is the b. It doesn't count the 0, it's just the y value. So what was the y coordinate? It was 3. So that goes right there. Y equals -2/5 x plus 3. And I know that almost all of you have done that GeoGebra assignment, so I will show you how easy it is to do this kind of thing on GeoGebra. Let me just make it a little bit bigger so that people in the back can see. So if we just type in right here, y equals -2 divided by 5x plus 3, we get exactly the line that you guys drew. See the y-intercept? How much is it? It's 3. And then if we take that guy, and I'm going to run over here to this point. So starting at 0, 3, and ending at the next point, which we found was 5, 1. Going from A to B, how much was the rise? It was -2, right? And I like the negative because we actually had to go down. The rise was -2. How much did we run? +5. And you could run another -2 and rise another -2 and run another 5, and you'll get to another nice point on this line, 10, -1. And you can just keep doing that left or right as far as you want, okay? So it's very easy to just check your answers. You can just type them right into GeoGebra. Okay, let's take a look at number 4. And we'll go to Sebastian. Okay, so again, our new favorite equation for today is this y equals mx plus b. So y equals 5x plus 4. Do you see the number that's playing the role of m? What is it? M is the 5. M is always the number touching the x. What is the b? It's 4. I'm going to put the plus sign in the front just to highlight it as a positive 4. You can just put 4. So we've got our two answers here. The slope in this case, the m is 5. The y-intercept is 4. And if I really want to make it clear that the y-intercept actually has 2 coordinates, what's the first coordinate? Always 0. And in this case, it's 4. Part B requires a little bit of work. Actually, the y-intercept is still easy to grab. How much is the y-intercept here? It's 5. It's just the number sitting by itself. So I'm ready to plug in 5 here, and I can put the coordinates. What are the coordinates? 0, 5. So that part's still easy. But finding the slope, it's actually a little bit of work involved because it doesn't look like a number times x. I'm just going to copy that part over here. It doesn't look like a number times x. So I need to do work to make it look like a number times x. So this is the first time we're going to do this exact thing. Do it a few times, it will become comfortable for you. First of all, I need to have a number right up there in front of the x anyway. What number can I put up there? I can put a 1. That doesn't change anything, right? It's really 1x. And here's the part that's going to feel weird to some of you in the beginning. I'm going to peel that x off. I'm going to write this as a -1/3 times x. Just peel the x right off. And to convince you that this is allowed, that it's legitimate, what can I put underneath x without changing it? I can put a 1. And then I can ask you, when you multiply two fractions, which is what I've written here, how do we multiply? Is it diagonals? No, we go straight across, right? Straight across here, straight across here. How much do you get on top when you multiply? -1x, or just -x. On the bottom when you multiply, you get 3. So -x/3, it's the same as what we had. So the way we're going to want to rewrite this guy is -1/3 times x. We peel that x right off. Just making up a quick example here. -2x/7. Can you peel that x off? -2/7 times x. Any questions on peeling off the x? Again, it looks strange until you've done it a few times, then you say, okay, it's legitimate. Just verify later on if you want. Just multiply it back and see if you get the same thing you started with. Questions on that? Okay, now that this guy right here is really the same as this right here, I'm ready to tell you what the slope is. The slope is always the number touching the x. What is the number touching the x? It's negative 1/3. That's the m. Sometimes you have to do work to find that m. Okay, and then finally part C, there's really a lot of work to do actually, because part C doesn't look anything like y equals mx plus b. So hopefully there's some space down here. Goal is y equals m times x plus b. That's what we're after. What letter is by itself in that equation? Is the y. So that's our first priority. Get the y by itself. That letter right there needs to be isolated to have any chance of it looking like y equals mx plus b. So let's see if we can isolate it. Do you first move the 4x or do you first move the 3? The 4x has to go first by subtracting it from both sides. So let's do that down here. 3y equals. So I'm going to subtract 4x from both sides. So we go 12 minus 4x. And now how do we solve for y? Divide by 3. Okay, so let's divide both sides by 3. Divide by 3, divide by 3. So I'm just going to write, I'll just copy the whole thing over here. 12 minus 4x over 3. Okay, so good news and bad news. The good news is what letter is by itself? The y. So that was part of the problem. The goal is still this black equation, y equals mx plus b. The bad news is the right-hand side doesn't look anything like we want it to. The left-hand side is good, it's just y. But we need that right-hand side to look like m, some number, times x, plus some other number. So first thing we're going to do in terms of rewriting this is to split this thing up into two fractions. Let me ask you this. If we had 1/7 plus 8/7, what would you do if you wanted to push them together? 7 on the bottom and then upstairs? Just be 9. I even want to slow you down. Can I write 1 plus 8? That's why it's 9, right? So everybody believes that if I have the same denominator, I can push them together and make one fraction. What we have over here, this 12 minus 4x over 3, it's already been pushed together. I want to split them back apart. It's really unnatural. This might be the first time you've been asked to do it. So we're going to split this into two fractions. It's 12/3 minus 4x over 3. Are we believers? Is that legitimate? It might be very unnatural, but it's okay. It's just going the other direction from what you might be used to. Okay, we can do a little better than this. Y equals 12 over 3 is really 4 minus, I don't like that it says 4x over 3. I need to peel that x off. So peel the x off. 4 over 3 times x. And then one last step. It's almost there. Again, the goal was this m times x plus b. That's the goal. It's just in the wrong order. The x part is at the end, but according to our standard equation, the x thing should be the first thing that we see. And the plus b should be at the end, but instead it's first. So we're just going to swap the order of these things. I have a 4/3 x. I'm going to put that first. I have a 4. I'm going to put that second. I have some blank spaces in there to insert pluses or minuses. You just have to put them in the right spots. They need to stay the way they were before. Was that 4 a positive or a negative? It's a positive. It's still a positive 4. Was this 4/3 a positive or a negative? Negative. It is still a negative. Okay? So we're switching the order. I'll make sure you keep the signs exactly what they were before. And now that it has the right form, it's easy to tell what the m and the b are. So I'll write our black equation right down underneath here again. M times x plus b. And then go ahead and write down what the m and the b are. Answer a question. You don't have to separate them. You need to get to the same m and b that we're about to get to here, but you don't have to show all these details. Yeah. Okay, so let's write down. What is the m? 4/3? Negative 4/3. What is the b? 4. So we can fill in the blanks up above with those two numbers. Negative 4/3 and 4. Any questions on that? I know it's not the most exciting process in the world, but it's one I need us to be able to do. Okay, if we're ready, we move on to the next page. All right, number 5. There's some context about this problem. I'm going to skip over the context. I'm just going to jump right to the like hardcore algebra for this one. So ultimately, the question we're asked for is this: find an equation for the graph. I just want to know what an equation of this thing is. So first of all, is this line increasing or decreasing? And don't say the answer out loud, but rather point. Up if it's increasing, down if it's decreasing. The reason I like everybody to point is that then it's not just the first person to say the answer, but everybody has a chance to weigh in. Okay, good. So everybody says decreasing on this one. So we're expecting what kind of a number for the slope? Some negative number. That's the only thing I can say. So the first thing I want is the Y-intercept. You can read it off the graph. What is B? It's 10,000. That's just reading what the Y-intercept is. So the B is 10,000. The other thing that we need to know is the slope. Well, we have ways to calculate the slope, but all of them involve having 2 points. So I'm perfectly happy using that green one as 1 point. And then you can pick any other point that's on this graph, but you got to make sure it's also on the grid that's in the background. So for example, this point right here, I wouldn't pick. It's really going to be hard for me to estimate the coordinates of that purple point because it's not on the grid. This point is a little bit better. How much is the x? At that point, the x is 10, so that's easy. But how much is the y? Maybe 5,000, but I wouldn't even want to play that game. So much better would be a point like that. You understand what I mean by saying it's on the grid? So pick a point that's on the grid. Pick 2 points that are on the grid. So I'll use these 2. You can use your own 2. The first point I'm picking is this 0, 10,000, and the second point is 12, 4,000. So go ahead and take a moment to find the slope. So we're doing a calculation, rise over run, change in y over change in x. Count boxes if you prefer. Somehow come up with a slope number and reduce it and check with your neighbors. All right, so I end up with negative 500. Did I do that right? Is that okay? Any questions on getting the slope? Okay, then if we have the y-intercept, the b, and we have the slope, the m, then we just put it together to write the equation of the line. Again, I'll write it over here in black. Y equals mx plus b. But we just changed the m and the b to these numbers. Y equals, how much was our m? Negative 500. X plus, how much is b? 10,000. Any questions on coming up with that equation at the bottom? Y equals negative 500x plus 10,000. Michelle.
This is a really stupid question I have. Why is YB?
Why are we using the letter?
Doesn't understand that correlation. How does Y equal B?
Yeah, it's a good question.
Not how does it become a third?
Yeah, it's a great question. Why do we use B for the y-intercept? And also, why do we use M for the slope? So let me ask you this. If the equation instead was this, would you be happier with the B as a choice? Would just call A the first number and B the second number? That seems reasonable to me, right? Just calling them A and B. Is that okay? That makes more sense than M and B. M and B seem both arbitrary, but at least if we do A and B, then we're starting at A and we're just picking the next letter. Okay, I think that this is where the B came from, and then at some point, poor A gave way to the standard letter for slope. That's my best explanation. I don't know if it's historically accurate, but that's my guess. Is that it was an AX plus B, and in fact that's going to come back to us later this semester. We're going to look at this kind of equation, which maybe you've seen before, AX squared plus BX plus C. So we like going A, B, C, and just do them in order, right? So if we like that, then AX plus B seems very natural. And then the B is reasonable it has nothing to do with the letter Y. It's just the second letter I needed to invent. But then I think the A got replaced with the M. Good question. Here's a nice little sketchpad thing for you. And if you check out this video later, you'll see it in case you missed the commands. But if I wanted to look at the graph of the one that we just did, negative 500x plus 10,000, where is it? Is it that line? Here, I'll hide the line that's already there. Yeah, the line that I'm interested in is way up there at 10,000 and way over there at, what number is over there? Is it 20 or something? 12? Right, so here's a real nice way. It's very easy to ask GeoGebra to go find the thing for you, or it's easy to go find it. Instead of having the mouse tool selected right there, you go to this last tool. What that last tool does, if you take the cursor here and you click anywhere in the white space, you can just drag around and very easily move the whole thing. I'm going to put it there. If you choose to put the mouse on top of the cursor, on top of the axis, see how it changed from the plus sign to just an arrow? You can then click and drag, and then things come down. And it actually doesn't take all that long. You can start to see the line. I only dragged once. I'm already up at 1,000, so I can just click here and bring us down. And oh, look, there's the line. And then we'll just move over a tiny bit. 10,000 there. I want to bring this guy in a little bit, so we'll just click on it and drag. And it takes very little time to go find a graph, even if it's far away from the standard axes. Okay. Questions on that? Okay. Good question. You can type in you can. Let me undo the stuff that I just did so that we can go back to our standard. All right, so I think here's our standard looking thing. I actually am not 100% on the command. The version of GeoGebra that I have is a little bit old. I know that the newer version that all of you guys downloaded has it. So I'm looking for a zoom command and I don't see it here. Try what? Control what? Plus. Yeah, that doesn't seem to do anything. There might be a way to do it on this one. I can tell you definitely there's a way to do it on the version you have, and you just type zoom, and then you say the X and the X and the Y and the Y, and it zips it right to that, just like on a graphing calculator. Yeah, They've made significant improvements since the version that I downloaded. Good question. Yeah. All right, coming back here, we're going on to number 6. And number 6, we're going to go to Jenny. Okay, so again, the goal is y equals mx plus b. So we need the m and we need the b. And there's an order in which we're going to find these things. You really can't find one of them without first finding the other. If you have 2 points, what can you figure out? The slope. We've been doing that since last class. So we first find the slope. So let's go ahead and find the slope. Again, subtract the y's over, subtract the x's. Be consistent in terms of the order. I got -3. Anybody else get that? Okay, so we've got our slope of -3. So here's what we're going to do. We're going to update our equation. Instead of y equals mx plus b, we're going to put y equals -3x plus b. So we started with our general equation in black. We got one piece of information, it's the slope. So then we just update our equation, -3x plus b. What's still unknown is the b. Now we can find the b. We couldn't find it until right now. So here's what we do. It is a fact that, for example, that point right there satisfies the equation of the line. And so does the other point. And every point on the line satisfies the equation of the line. So what we're going to do is plug in. Instead of x, we're putting -1. Instead of y, we're putting 4. I'll put the letters right up here. X first, then y. So let's write it. Instead of y, how much is the y coordinate at this point? It's 4. Equals -3 times, how much is the x at that point? -1. Plus, how much is the b? I don't know, but we're about to find it. So all we did is picked a point, plugged it in for the x and the y, and now we can solve this equation for b. So I got b is equal to +1. Now I picked the first point plugged in. It would be pretty terrible if picking the second point gave you a different number for b, right? The b is b, it's a number. It can't be different depending on what point you pick. So you don't need to copy this if you don't want to, but I'm going to plug in the other point just to see what happens. At the other point, how much is the y? It's -5 equals, I'm copying this purple equation, -3 times x. -3 times 2 plus the b that I still don't know. That equation looks very different from the first one we solved. But let's see what happens here. -5 equals -6 plus b. Add 6 to both sides. B equals 1. You'll never need to do it twice, but I just want to give you an example that shows it makes no difference which point you pick. A lot of times when there's a choice, some students get a little bit antsy. How did you know to pick that one? I didn't. Works no matter what you pick. So then our final equation of the line, it used to be -3x plus b. Now it is -3x plus 1. Any questions on that? Seems what? It will be useful. I mean, I should have prefaced this whole class by saying, look, these techniques are not all that interesting, but they're giving us the ability to work with lines. And there are lots of interesting things that are lines, and we'll see plenty of them. For right now, we're just developing our toolbox. Okay, so that's the negative 3x plus 1. That's the equation there. And there's one more equation I wanted to look at together, and then you guys are going to do the group activity. So there's a little stuff I'm going to skip through. I'm just going to jump to the punchline of this thing here just to save a little bit of time. I'm going to write down another equation of a line. Used to be y equals mx plus b. That's our favorite new equation from today. There's another equation of a line that's this. Y minus y1 equals m times x minus x1. So just write the equation, then we'll talk about what all those funny pieces are. Okay, so here are what the pieces are. What letters are the same in both red equations? There's the y that's the same, so I'm just going to put a check mark. The y is still y. What else is the same? The m is still m. The third thing is the same. The x is still the same as the x. So the only difference between these equations, the first equation has what letter? Has a b. We don't have that in the other equation. The other equation has a y1 and an x1. So what does that represent? Well, it just represents the coordinates of the point that you're given. X1 in this problem down here is 4. I'll put a comma there to separate. The y1 is 3. The x1 and the y1 are just the x and y coordinates of the point that you're given. So I want to see that second red equation there in action. So let's start plugging into that equation. We'll go to number 8. We'll get our next reader. Michelle, can you read number 8, please? Thank you. Okay, so point slope form is this brand new one right here. And let's go ahead and use it. So we're starting to plug in. Y minus. The y just stays y, it's in our answer. The y1 is the specific y value of the point. How much is the y value at that point? It's 3. So that y1 becomes 3. Equals. The m is still the slope. We're fortunate, it's just given to us in this problem. How much is it? Slope is 2, that's given. Parentheses. X, still x. Minus. The x1 is the x coordinate of this blue point, which is 4. That's it. That's the equation. So it can be intimidating to see those little ones sitting down underneath. Why are they there? Well, this actually kind of gets to Michelle's question. Why did we use B to represent a y coordinate? That's not very natural. It's a whole lot more natural to do what we did in this equation. We used y with a little subscript there to say, okay, we have a single point. We have one point given to us. Let's call it x and y, but I don't want to call it x and y because those are variable names. They're reserved. So let's call it x1 and y1 to indicate we have a point given to us, and we've got an x coordinate and we've got a y coordinate. There's our equation. That's it. If I wanted to continue and write the equation in slope-intercept form, well, that's the first red one, the y equals mx plus b. So let's do that here. I'm just going to rewrite this by first doing what with this 2? Distribute the 2. And then solving for y, because I want it to look like y equals. What do I do to both sides? Add 3. So I get y equals 2x minus, add 3 to that very carefully, 5. So I've now got two different equations on the board circled in purple that both represent exactly the same line. And to try to convince you that they represent the same line, we're going back to GeoGebra. So let's get rid of some stuff. Get rid of that too. Okay, the first equation was what? Y minus 4? 3 equals 2 times x minus 4. There. And I'll get the grid up here. All right, so that's the one line. Now I'm about to hide that line. So let me type in this other one here. Y equals, what was it? 2x minus 5. Now before I hit enter, I'm going to hide this line, because if I hit enter and they're both the same line, you're not going to see anything, because the one is going to land perfectly on the other. So I'm going to first hide that line by hitting that button, and then I'm going to come down here and hit enter and bring the other line, which is exactly the same as the first line, right? So here's the good news. The good news is I actually don't really even need you to ever use this y minus y1 equation. You can do everything that you want with the mx plus b, and it seems like in the last, say, 10, 15 years since I've been in high school, I feel like there's been a shift in terms of that second equation, the highlighted one, really not getting as much attention as the first one. So if you're comfortable with mx plus b, do everything with mx plus b. I don't think I'm going to go out of my way to make sure you can use the second one, because like I said, you can do everything with the first one. So what I'd like you guys to do, we have 26 minutes or so. If you go to the middle of